the visiting lecture for the subject of machine learning for the students of STEKOM University, Indonesia. Now, I would like to thank our management for giving this opportunity for our department to deliver and share our knowledge globally, especially for the students of STEKOM University in Indonesia. And also, I would like to thank Ms. Novita and Sari, MC from Indonesia, STEKOM University, and Dr. Joseph, Rector, STEKOM University, for giving this opportunity for our faculties as well as myself for our institution to deliver this guest lecture. Thank you. Thank you for giving this opportunity. Now, I would like to welcome our Professor B. Moohambigai to hand over the session. Yes, please.
A very good afternoon to one and all over here. And my Moohambigai, Assistant Professor of Arunai. I would like to share a few experience or a few knowledge which is gained by me, and you can able to watch it later. Does my screen is visible for everyone? I hope so. Today I'm going to present the topic of machine learning. You might have heard the word the machine learning, right? So from this we can infer that we can able to train the machines so that it can learn from the training. Okay. So machine learning, how can disturbance in the table? One second. Okay. So the table of contents that we are going to refer is that how to redefine a machine learning, an advanced algorithm and architecture, deep learning frontiers, and then optimizing model performance, scaling ML for real world impact and real world applications, the future of machine learning, a few case studies. And what do we mean machine learning? Before we come to know of the topic, machine learning, how we the humans will learn. We generally learn from our environment as well as from the childhood we learn from our parents, right? So our parents will introduce each and every object. So suppose when it tends to be fruit, if the fruit is found to be red color and if it is going to have a small apex at the topmost level, and we can automatically they can say that it is a apple. Okay, so each and every fruit is going to have different features. So these teaching is generally done by our parents to us, and normally we also learn from various environments. So once we go outside, we can observe the nature or any other objects within a world, and we can came to know that so that is a particular object. So there are two kinds of learnings are there. Once we the one thing is that we learn from our parents, and the other one is that we just explore the environment and just gather the knowledge. So likewise, how can we make the machine to be able to learn? Okay, so here comes the machine learning. So this is a subset of artificial intelligence, so which enables the computer to learn from the data and make the predictions without being explicitly programmed. We can able to enable or to train the machines the three types of learning. As I said that the humans can learn either by from our parents, and we can learn from the nature. The machines also which can be learned. That machine also learn with the help of two to three different types of learning. Okay, so here's the first one. So that is supervised machine learning. In supervised machine learning, here we are going to have a labeled data. So in labeled data, which, this type of learning, in this learning here, a model is trained actually using labeled data. So what I mean by labeled data is that the data set consists of both input and output pairs. Okay, where the correct output label is known. So let me tell you a simple example. If our parent will talk about what are the features of a particular fruit, for example apple. So once you go anywhere, so from the learning past experience, you can able to identify wherever the apple is. Okay, so if a group of fruits is provided to you, you can directly identify which one is the apple and which one is the next other fruit. So likewise, if we give the information to the machine with the help of both input and output pair, suppose if we train the machine with the help of the input as well as this will be the corresponding output, the machine can be able to learn. So this is generally done under the guidance, or we can say it is done under the supervision of a particular person. When you take a particular person, it is done under the supervision. Okay, so here the model is trained using a label data, which is nothing but an input output pair, and it is also pre-processed to predict the outcomes and classify the data accurately. So here I have given you a simple example. Here it consists of an animal such as camel and then elephant and then cow. So this is nothing but a labeled data, and once it is fed into an algorithm, it will do all the pre-processing work, and finally it can able to conclude that which animal is an elephant, camel, and then cow, based upon some of the characteristics that we have enabled the machines to learn previously. So this kind of learning we call it as a supervised machine learning. And then next comes the unsupervised machine learning. When you go for unsupervised machine learning, here it doesn't consist of any labeled data, right? So where the data set consists of input output pairs, and similar likewise input is only given, the output can be which can be learned by the machines once it explores to the new situations. So this is the input raw data which is given in a clumsy manner. So there is no supervision. It has to learn from the own environment by its own interpretation. Let me give you a simple example. Suppose if you want to move from one city to another city, right? So without any guidance, if we go alone, we just explore each what are all the intermediate pathway while we are traveling from one city to another city. So and then suppose if the same situation happens for me, and I can from the previous past learned experience, I can able to explore those points and reach the destination. So this we call it as an unsupervised learning. Here the input and output pair is not initially known to everyone. Okay, so likewise we are also making the machines to learn from the situation by its own. So this we call it as a supervised learning. So from this unsupervised and supervised learning, the machines can able to draw the insights as well as the patterns from the supervised and the unsupervised learning, which will be helpful for predicting the outcomes. So generally it is used to predict the outcome or future. And then there are various kinds of supervised learning algorithms available, as well as unsupervised learning algorithm. And when you take a supervised learning algorithm, here there are two different kinds. There is classification and then regression. So when you take classification, classification is nothing but we are dividing the entire group into two or more groups. So within a group, each and every data sets or every data point here, it is going to have similar features or characteristics. So each and every group vary with each other with the help of a difference. So if a common feature is found out within a data points, we can club together to form a group. So that we call it as a classification. And one more example is that when you consider an spam mails, right? So when you consider a spam mail, how can we identify the spam mails from a normal mail? Is that spam mail may consist of certain keywords such as congratulations, you have won $10,000, etc. like this. So from the particular word itself, we can able to find out which is a normal mail and which is a spam mail. Okay, so for this kind of classification, we can go for the classification problem. And then next comes the one more example of supervised learning is that regression. So regression generally includes continuous value instead of categorical values. Here it includes and continuous values. So when you take, so this is generally used for stock market prediction, right? So that is the predicting the stock market prices using a live data, because the stock market values will be changing for each and every moment. So this kind of learning will comes under a supervised learning algorithm. And unsupervised, when you go for unsupervised learning, so there are also two different types. So the first one is the clustering and the dimensionality reduction. So what I said previously is that we are going to group a similar data points. So that comes for clustering. And then the next thing is the dimensionality reduction. Why we go for dimensionality reduction? As you know that if n number of attributes or have to be visited, the number of, since the number of attributes is included, everything cannot be explicitly shown within a representation. So if it is very easy if we represent with the help of two-dimensional instead of three-dimensional. So automatically we need to, instead of to go forward that, we need to go for several techniques, that is dimensionality reduction techniques. So there are various dimensionality reduction techniques available. So the first one is that PCA, that is principal component analysis, and then TSNE is also available. And apart from this, here we also have a K-means algorithm, and then the hierarchical clustering, etc. like this. Okay, so I conclude that this supervised learning is generally under the control of a supervisor, where the labeled data is given. So accordingly, if a new situation has been provided to a machine, so the machines can easily learn with the help of an predefined knowledge. Then comes the reinforcement of machine learning. So this is somewhat a variant from supervised and semi-supervised learning. So in reinforcement learning, generally we'll be having rewards and punishments. So this is a type of ML where an agent learns by interacting with an environment to maximize the cumulative rewards. Okay, so normally the agent will take an action. So based upon the action, it can move from one state to another state. So for this, I can give a simple example. Suppose when you consider our parents, okay. So sometimes our parents will say, if you do this work, I'll give you money, or I will allow you to watch TV for a while, right? So what will be actually the student can do, or student or a child can do, automatically they are enthusiastic to finish those work at a predefined time. And after finishing the time, they will be rewarded from the parents. If they are not going to fulfill the requirements, automatically a punishment will be given. Okay, the punishment should not be crucial. So, but a mild punishment can be given. Suppose if you are not going to finish it within a time limit, automatically you are not supposed to play out, etc. like this. So here the agent will always act in order to gain a maximum rewards. So that is the concept behind reinforcement learning. Okay, and then what are the training process? So how can you learn? So from the training process generally involves the agent explores different actions, and it makes the improvements based upon the rewards using trial and error method. So this trial and error method have been I think it have been, maybe we might have been learned in the previous days also. It has been proposed by a few scientists, the trial and error theory. So based upon that, they have generated a reinforcement machine learning. And then next comes the hypothesis in machine learning. Before knowing about an hypothesis in machine learning, so generally what we have to specify a hypothesis is that it is generally a function, right? It is generally a function that maps the input features to output predictions in a machine learning model. So usually when you go for a research, generally we'll deal with qualitative and then quantitative research. So when you go for quantitative research, here we need to consider two different types of hypothesis. So that is null hypothesis and then alternative hypothesis. So the first thing is that what do you mean by hypothesis? It is a machine learning. In machine learning, it is a function that maps the input data to the predicted output based upon the learned patterns. Okay, so what is the main goal of hypothesis is that it generally aims to generalize well to new unseen data, providing the accurate predictions. So by looking about to a diagram, a hypothesis generally traverses from, it includes the mathematical functions, predicts the relationship between two variables, or it may be two statements, and according to the predictions, it will provide an output. Okay, so once the previous data has been known by the machines, so based upon that, if a new environment or new situation is provided to it, it can act accordingly. And what I've said about this null and alternative hypothesis, this plays a major role. And when you consider a null hypothesis, it is generally denoted by H naught, and alternative hypothesis, it is denoted by HE. So a null hypothesis a null hypothesis is nothing but a statement about a population parameter, and alternative hypothesis is a statement that directly contradicts the null hypothesis. So when we want to say about a null hypothesis, that suppose if you are going to take two different variables, so there is no relationship between those two variables. Suppose if I give an example, right? If a particular person fails to have his breakfast, so that he is actually he failed in the exams. Is there any relationship? No, right? So there is no correlation between these two statements. Since he doesn't have any breakfast, he cannot. He just failed in the exam. There is no correlation. Okay. So here this comes under the null hypothesis. There is no relationship between the data. Okay. So here the model prediction is no more better than the random guessing. And when you go for alternative hypothesis, And if you go for alternative hypothesis, in the case of alternative hypothesis, I can say if a person doesn't study well for the entire year, he cannot perform well in his examinations. Okay, so upon considering these two statements, so there is a correlation, right? If the person fails to read or study throughout the year, he cannot able to perform well in his final exams. So this kind of statements, if there is this kind of statements, will have a relationship between these two, right? So such kind of a statement, we call it as an alternate hypothesis. So a researcher will always try to find out in order to reject the null hypothesis. If we reject the null hypothesis, then only an alternative hypothesis can be accepted. Okay, so in case of a null hypothesis, it may include similar variables, operators just like this, equal to, less than or equal to, greater than or equal to. Likewise, in alternative hypothesis, it may also include greater than or less than symbol. Okay. So, what do you mean by in hypothesis space? So, hypothesis space is the set of all possible hypotheses. So that a machine learning model can choose from to map the inputs to the output. What is the main purpose of using a hypothesis space is that it defines the range of models the learning algorithm explores during the training to find the best one that fits the data. So when you take a hypothesis space is nothing but it generally consists of a collection of set of hypotheses. So let me give a simple example for this. Suppose a person has been accused of theft, right? So here there may be several reasons behind that. A person may be in economically poor, so that he might steal a particular product, or else the owner of the product itself gave the permission, or he has been arrested due to mistrust or misinterpretedly he has been arrested. So there are various factors, right? So each and every factor we call it as an hypothesis. Altogether, these hypotheses will be collectively stored in a particular space that we call it as an hypothesis space. So what is the outcome of this thing is that we need to find the best hypothesis that fits the problem. A person steal a particular product. So what is the reason behind that? If he goes for any judgment, right? So the judge will consider all those factors and he will find out what is the appropriate reason for his theft of that particular product. So this we call it as an hypothesis. Altogether, many the n number of hypotheses are available in hypothesis space. Upon them, we need to find out which one fits according to our problem. So that is very important, hypothesis. And then redefining a machine learning. Okay, so in this we are going to see about an evolution from traditional to advanced ML, advanced challenges and opportunities, and the role of big data in complex ML systems. So far I've listed out a few basics about an machine learning. So now we are just going to see how we can gradually move from a traditional to an advanced ML learning. In traditional ML, generally this type of ML generally focus on simple statistical methods as well as simple models. For example, let me take a linear regressions, right? So when compared to an advanced ML, this is going to focus mostly on deep learning, transfer learning, and scalable architecture. So when you take a traditional ML, so this will generally focus on manual feature extractions. Suppose if you are going to predict the outcome, right? N number of features have been given to us, that is given to a machine. So it may not consider each and every feature. For example, if you consider a date of birth as well as date of birth as well as age in DBMS, so the machine will check whether it is mandatory for both the features to be included in that. So automatically we can say age, that is age feature is not needed, because once a date of birth have been given, automatically age can be derived, right? So here the age we call it as a derived data type. So it will select which are the necessary or predefined features required to solve our problem. So it will eliminate the remaining parameters or remaining features from the particular tables. Okay, so this generally deals with the manual feature extraction, as in case of traditional one. And the traditional one is used to store structured data like tables and spreadsheets. As we know that each and everything each and every value within a spreadsheet, it is generally represented by row and column representation. So this we call it as a structured data, right? Since it is going to have a predefined format, we cannot randomly store those values. So a traditional ML mainly focuses on structured data. And when you go for when you go for the third one, it performs well on simpler problems with clear patterns. So if the pattern is clear, we can able to make use of traditional ML. And when we go for the advanced ML, it automatically learns the feature through the layered neural networks. Okay, so here why we go for advanced ML learning is that here it generally deals with an unstructured data, because we are not sure about the various n number of people's who is doing the searching, or searching with the help of a predefined word. Okay, suppose each and every user may vary depending upon the text messages. Suppose if I want to find out the definition for ML, I can say that I can make a Google search by giving the keywords, give the definition for ML. Okay, some other person will give in different way elucidate ML likewise. So the searching may also differ, and moreover everything cannot be comes under the searching will not comes under particular specific type. If I'm doing my searching with the help of giving a text message, or some other person will also give the images, and some may give a voice search, for example audio search, that is voice search, with the help of can you give the definition or can you give the explanation for ML. So such kind of data we call it as an unstructured data. Because in day-to-day life n number of users are using the internet resource as well as the social media. So through this, a huge number of enormous amount of vast amount of data have been emerging day to day life, and we are it is not restricted to use such kind of only text alone. Okay, so since it is arriving from various sources, the data may be in of any type. To handle those data structures, so to handle those unstructured data, we are in need of advanced ML. And what are the challenges we need to perform? One second. What challenges we are facing? Why we are moving from a traditional ML to an advanced ML? So the main challenges is that handling what I've said just now, handling massive and then high dimensional data. So massive, a huge volume of a data. As we know that big data mainly contributes much to the machine learning. So the data may be arrives from various sectors in terms of various templates, text, voice message, video message, etc. Right? So that may be one of the main challenge we need to focus on. And every data should be interpreted, and every data should be handled with care, so that it may not lose the accuracy. Right? So it may not lose the accuracy. So this is one of the challenge. And then the next thing is that overcoming bias and interpretive issues. But bias is that suppose if I'm deviating from the actual value, right? If I'm deviating from the actual value, so I need to find out the difference how far I am deviated. So this kind of problem also tends to be a very challenging one in nowadays. And then the next thing is that solving previously intractable problems. So what I mean by intractable problems in real world life is that optimization station. Right. So suppose when you take sectors just like this flight scheduling, etc., like this. So we need to find out an optimal solution in real time scenarios. What is the arrival time of a flight, and whether any vacancies or that, or suppose if the time has been changed, does it be properly intimated to the users, that is passengers. So such kind of situations may arise in an enormous way. So the situation may fluctuate, so everything doesn't happen in a right way. Sometimes there is a deviations, right? So to overcome those possibilities also, we are just focusing more on advanced ML. And suppose when you take an cryptography, that is a cryptographic technique. So in cryptography, we may be dealing with a large factorization method. So it cannot be done manually by the humans. If it is going to be, for example, if it is going to be a two-factor, I can find it simple, right? So if I'm representing the value which is going to have, for example, 10 places, okay, 10 places. For example, if I want to find out the factorial of 10,000, it is not probably easy, right? So, and these are the things we need to focus on. And when you take, for example, like game theory, n number of moves are involved in the game theory due to the n number of possible moves and combinations. So accordingly, we need to find out generate an algorithm, so that the credit, whether a credit has been given to the particular user, or if it can be dropped, that is the values can be dropped. So here and then when you take one more real-time example is that driving automation system. So as you know that here self-driving cars have been emerged worldwide. So one of the famous self-driving cars have been introduced by a Tesla company. So here there are various levels available. So when you take a level 0, there is no automation over here. When you take level 0, there is no automation. And when you take the level 1, there is a driver assistant. Suppose when you take the level 2, there may be a partial automation. Okay. So likewise, we need to consider what are the real-time problems available and how we can address those problems. So that is an opportunity for enabling the advanced ML, that is driving automation and then creativity. And next comes the role of big data and machine learning. So this plays a major role. So first, when I say about an improved model accuracy, right? So here the big data provides a more example for training, and almost it is helping the machine learning models to learn the better patterns and make accurate more predictions. So that is the first one, is that generally it would improves model accuracy. Second one, handling the complex problem. Since I've said that large data sets have been arriving, right? So, and when you say about the complex tasks, the complex task may be image recognition and then natural language processing, and then what are the recommendation systems that require the vast amount of data. So, the second thing is that handling a vast problem, and then data variety. So, when you take a data variety, the data may be classified into structured, semi-structured, and structured data. So here also there is a problem arising, that how we can draw the conclusion, or how we can convert those, how we can handle all those types of data. So that need to be addressed. So the data variety, and then training deep learning models. Okay, so deep learning models. So since a number of data arises, so once you go for a deep learning, so here deep learning may involve a number of layers. The layers may be probably might be of a single layer, or it may be a multi-layer concept. Suppose when you take a multi-layer concept, it may have one or more hidden layers. And mainly it also the other thing, it also deals with real-time predictions, right? So how can autonomous vehicles and then fraud detection, etc., like this. In case of a fraud detection, we can slightly avoid the fraud detection method by means of enabling the hash value functions, right? So these are the few things. It enables the better predictions, and it allows for more accurate predictions, enable the real-time decision making, and it requires the robust infrastructure, and it also requires the data quality and governance. And then what are the advanced algorithms in architecture available? As I said that previously in normal, the basic level of ML include several algorithms, such as the classification and then regression algorithms, just like that. So when you take an advanced algorithm level, here comes the transfer learning, ensemble methods, as well as the graph neural networks. So what do you mean by the term transfer learning? So transfer learning is that we are just going to reuse the knowledge from a pre-trained models for new tasks. Okay, we are not going to deploy a new model. Instead of deploying a new model, a pre-trained model which is going to have a well knowledge about the regarding the training sets. So that can be reused. So that we call it as a transfer knowledge, or how can I say? If we learn a particular thing from our parent, okay, we'll just convey those things to the others. So just I am transferring my knowledge, what I have learned previously. I am transferring my knowledge instead of establishing, or instead of introducing a new person to explain to someone. So I have learned from my ancestors or my parents or my tutor, wherever. Okay, so now I am conveying to you. So this we call it as a transfer learning. So what is the beneficial use of benefits of using a transfer learning, is that it generally saves the times and computational resources. So an example is that BERT, which is trained on language data to classify the customer review. Okay. So before that, okay. Okay. So here, in case of transfer learning itself, will be having several types. That is inductive learning, as well as transductive learning, and then unsupervised. So when you take an inductive learning, the source and target tasks are related. The source and target tasks are related, but somewhat different. So when you take an transductive, it depends upon the same task, but different data distributions are available. So when you take an unsupervised, there is a knowledge transfer without labeled data. These are the few types of transfer learning. So we can make use of the pre-trained models instead of a new model is going to be exploited. And then next comes the ensemble methods. So this is a very important method in ML. So here I have just listed out the two thing which is most important, that is bagging and then boosting. So when you take a bagging, it reduces the variance. It reduces the variance by training the multiple models on different random subsets of training data and averaging their predictions, right? So, and here, what is the main usage of, or what is the main beneficial feature of bagging is that here we can do a parallel processing. Since we take each and every model, okay, so each and every model and make those model to train on a particular subsets, and if it is once it has been trained, so everything can be processed in a parallel manner in case of a bagging. So when you take a boosting, this is also will just identify the weak learners. So instead of identifying the strong learners, we'll identify the weak learners to create a strong learner. I can give a simple example for this. So several in India, several apps are available for educational purpose. So likewise, one of the most popular app is Byju's app. So the Byju's app, how they will provide a content to the user is that initially they will conduct a test for each and every user. So depending upon the performance level of each user, they just provide the content to the user. So the content provided to each and every user differs based upon their performance. So the content is not same for all the persons, right? So likewise, we can say that we can identify the weak learners. So suppose I am well versed in numerical interpretation, or some other maybe maybe well versed in the science or physics, etc., like this. Okay, so based on my performance level, they'll identify where I am lagging. Suppose if I am not strong in physics, so they can just identify where I am lagging, and they can post the contents which is relevant for me. Okay, that same information will not be same for each and every user. The other person might have be lagging in mathematics. Okay, so according to their level of the knowledge, they will provide you the content. So likewise, this boosting is used to identify the weak learners to create them as a strong learner. Okay, so how can they achieve this? By directly correcting the mistakes made by the previous model. Likewise, if it is implement, I'm saying about a person, right? So if you are going to make a model, and several models are involved over here, and if suppose if a particular model has been not performing well, so that model has to be identified as a weak learner, and that model has to be trained so that in order to get a better performance and a better outcome. Okay, so here the models is actually trained sequentially. So each model learns from the errors of the previous one. So previous one, and it will correct itself, right? So in case of a bagging, we'll do a parallel thing. In case of a boosting, a sequential work is done. And what are the few examples I can say for bagging is that random forest, and then bagging classifier. And when you go for boosting, it involves the ADA boost, and then gradient boosting, etc. Okay, so what is the main thing regarding your ensemble methods is that it just avoids the overfitting. So I'll show you in the next upcoming slides about what I mean by an underfitting and what I mean by overfitting, and what is the good fit for a model. So I'll tell you now, okay, in the upcoming slides. And next comes the graph neural networks. So in graph neural networks, we'll be taking the hypothesis space, and is the set of all possible. What I've just said about what I mean by hypothesis, and then hypothesis space, right? So when you take an hypothesis space, it is a set of all legal hypotheses, and yeah, this hypothesis space may consist of n number of hypotheses. From this, we need to find out which hypothesis plays a major role and which best suits for the particular problem that has to be identified. So this can be done with the help of a graph neural networks. So here, when you consider here, it consists of various stages, that is input, and then hidden layers, and then output. Okay, excuse, and then output. So in what is the main purpose of this is that it defines the range of graph-based functions the GNN exposed to find the best solution. So what I said previously. So instead of having n number of hypotheses, I need to find out where I am lagging, right? Or I need to find out what is the best solution that fits my problem. So that need to be done with the help of graph neural networks. So here comes the hidden layer. Here we can have n number of an hidden layer, and here the thing relu is nothing but an activation functions. So this activation function is used to overcome the problems arises. How far we are from the actual value, right? Suppose if what if my predicted value is far away from my actual value. Suppose if I am consider my actual value as 1, but I have predicted it as 0.8, right? So we need to find out the difference, how far it is deviated. The deviation is nothing but 0.2. Okay, so that will be reflected, or that will be overcome with the help of making the machines to train with that particular deviations, and in order to make a correct predictions. So that is done with the help of an ReLU function, the loss function, which we call it as a loss function, that is generally done with the help of an ReLU function. And then the next comes the deep learning frontiers. So under deep learning frontiers, we'll be going to focus on neural architecture search and then generatory advanced real search. So what I mean by an neural architecture search is that it generally automates the design of neural network architecture to improve the performance. So what is the main goal of is that it is used to find out an optimal or near optimal architecture that outperform manually designed ones. How it works? So it generally explores through a defined search space, possibly with the help of various algorithms, and it evaluates the architecture performance based upon the performance measures such like that accuracy. Okay, so a simple few diagram has been listed out. So here it includes a search space. With the help of a search method, we are just going to focus on a search architecture. And suppose if I find a method which is good enough, we can proceed to find out an optimal architecture. If it is not so, again we can make use of the search method in order to find out the best method that suits our problem. So a few search types, or what I've said previously in types of ML algorithms, that is ML learning methods. So reinforcement learning, or it may be an evolutionary algorithm, or gradient based, or Bayesian optimizations. And what is the main benefit of this one is that it automates the architecture design process. Okay, and moreover, it can also discover the better performing architecture, and it is potentially more efficient than the manual design. And what are the main challenges that we are focusing neural architecture search is that high computational cost and time complexity, and moreover the risk of overfitting if not properly tuned. And then next comes the generative adversarial network. So in generative adversarial networks, the hypothesis space refers to the set of possible generator and discriminative models that can be learned to generate a realistic data. What is the main purpose of using is that it is used to define the range of models which is explored by the generator and the discriminator to improve the quality of generated data and distinguish it from real data. So real samples have been given to an generator, right? So from that particular samples, it will check that whether the model works well on those particular samples, and if it can be able to discriminate among those samples, and if the final outcome is feasible for our problem, we can directly access that. Or suppose if it is not so, we just again need to refine or fine tune that particular training models in order to provide a correct output. And then next comes the optimizing model performance. So here we are going to focus on advanced optimization algorithm, hyperparameter tuning, and handling the overfitting. And when you take an advanced optimization algorithm, these are the few popular techniques. The first one is that Adam, and second one RMS prop. And if I want to say about a few things about Adam, which is used to combine the momentum and adaptive learning rates. So here it actually adjusts the learning rates for each parameter based on past gradients. So when you, what is the main advantage of Adam is that faster convergence and stable training. Stable training is that if a model is able to train on with the predefined training data sets, it works well, right? So if a new training sets have been given to that particular model, we cannot assure that it will give the same performance as like that of previous training data sets. So that is done with the help of this one. So and then when you go for RMS prop, so this is generally used for optimization for noisy data. So this will actually adjust the learning rate, which is based upon the moving average of squared variance. So this is generally used for optimizing a noise data. What is the main advantage of this RMS property is that it can handle the noisy data as well as, and it also perform a stable training. And the main disadvantage here we are going to focus is on is that no momentum, and it requires careful hyperparameter tuning. Okay. So when you come for hyperparameter tuning, here comes the flowchart. The first one is the baseline model, optimize feature set, model hyperparameter and architecture search, and then improve model, and then best model. So, since as I said that if the output that we gained is not of up to our up to a satisfaction level, we need to tune the parameters in such a way so that an optimal solution has been derived. Okay, so when you go for a baseline model, what is the main goal is that quickly we need to build a simple model to establish a performance baseline. What is the action involved over here is choose a simple algorithm just like that linear regression, decision tree, and then use the basic features and evaluate the performance. So basic baseline model is that we need to choose the simple algorithm, just linear like linear regression and then decision tree, right? So when you go for linear regression, why we are making use of linear regression is that we need to find the correlations between the variables, right? A correlation whether there is a dependency or independent, if these if two variables or two features are independent of each other. So in order to find those correlations, we can go for a simple algorithm instead of going for a complex algorithm. And then the next thing is that optimized feature set. So the main goal of optimized feature set is that here also it improves the model performance by selecting or enhancing better features, right? So instead of taking the features of, if I want to find out, for example, if I want to find out whether the person is brilliant or not, right? So whether the person is brilliant or not, I can include various attributes. So I can say about if I'm performing, let me take that, if I'm performing well on my studies, right? So I need to check whether I am well on studies. Suppose if I'm taking the characteristics of mine, for example, the height and weight, if suppose I'm taking those characters, height and weight, these are all not relevant to the outcome, right? My outcome is that I need to find out whether I'm performing well on studies. Okay, how can I find out what are the basic thing or features which is required? So the basic or feature things requires is that you can make or you can provide an assessment test to me, right? So with the help of assessment test only, we can you can able to conclude that I am performing well on my studies with the help of various tests performed at various stages. That is, at the end of every 2 months or end of the every 3 months, it may be the exam may be in an online mode or it may be an offline mode, or it may be an oral type of questions, by posting the oral type of questions or getting with the help of a Google form, etc., like this, right? So here we need to identify what are the features which is necessary in order to provide the output uh, properly, right? So what are the features which is not relevant should be removed. So that here we call it as an optimized feature set. Okay. So the main action involved here is feature selection, transformation, or creation. This generally also include an example for this optimized feature selection is that we can go for scaling, encoding features, and then feature interactions. Right. So when I take this two variables, that is date of birth as well as the age, both are interrelated with each other, right? So once I give a date of birth, automatically and my age can be calculated. So from this, I can identify these two variables are dependent on each other. So here in this scenario, we need to find out what are the variables required for our problem and which is not. And then the next comes is the model hyperparameter and architecture search. What is the main goal over here is that fine tune the model's hyperparameters for better performance. And the actions involved here are that is the method involved here is grid search. We can try all the possible combinations. Okay. And the other thing is that here I have given grid search. Apart from this, random search is available. And the next comes is the Bayesian optimization. These are all used to find out the optimal settings for the hyperparameter. And next comes the one thing, the next comes the early stopping. So this early stopping is used to prevent the overfitting by halting the training when the model performs on the validation set stops improving. So if you find that particular situations here the performance is well and good, we cannot able to proceed further, right? So there itself we can stop. So that we call it as an early stopping. So with the help of a early stopping, this ensures the model doesn't continue to train on noise and generalizes better. And then next comes the improved model. When you go for improved model, the goal is that build a redefined model which is based on feature selection and hyperparameter tuning. And the action involved over here is implement and evaluate the model with the optimized features and hyperparameters. And finally, upon making each and every model to be checked out here. Upon that, I need to find out which model best suits our problem according to your problem that we are posting, right? So here, select the best performing model from the previous steps. So here it may involve several models. If a model is not providing an accurate value for my, or it is not providing any solution to my problem, I can make the model to retrain itself, and finally we can come with a better model or best model. So the last thing is that best model, select the best performing model from the previous steps. So here we compare the performance on the test state and choose the model with the highest accuracy or lowest error. So several evaluation or comparison techniques generally includes cross validation techniques. So an example for cross validation techniques is that k-fold and then t-pad test, etc. like this. So we can evaluate the performance in each and every model with the help of such kind of things. And the most important thing is that what I said, I've said a few or more times about overfitting, underfitting, and then optimal fitting, right? So here I've listed a simple graph regarding that underfitting, optimal fitting, and then overfitting. So when you take a regression and then classification, so these regression and classification comes under supervised learning, and how it performs well, how the data points can be plotted. So here comes the first diagram. So these are all the data points. So we know that everything will be represented in terms of a data points. Each and every data points is going to have an x and y value, right? Suppose if I draw a line just like this, if I draw a line just like this, here we cannot cover all the data points over here. When we plot a graph, our maximum thing is that what we try to find out is that we need to cover all the data points within the diagram, right? So but here when you consider this line, it is not covering each and every data point. So these here some of the few data points which may be scattered over here and here over there. So this we call it as an underfitting. So when you say about an underfitting, here the model is going to work well on trained data. It is going to work well on trained data, but not on all other data. For example, if I say that if I'm taking two breeds of dog, right? If I'm taking two breeds of dog, and if I provide those two breeds, and I'm conveying to the machine such like that it's going to have a feature just like this. If it comes under this feature, this will be a particular dog. So I'll make the machine to learn about only two dogs, two breeds of dog. Okay, if a new variety of a dog is provided to that machine, provided to that new model, right? Provided to that model, it cannot able to identify that particular training model. So it generally works well for a training data, and not for unseen data. Unseen data is that new upcoming data. So in such a case, we say that it is nothing. It is under fitting. It works well only for a trained data and not for all. Okay, if a new situation is provided, it doesn't perform well. So this we call it as an underfitting. And then when you go for we go for an overfitting. Okay, see this overfitting and the fitting, it is used to connect each and every data points that is available within a space. What is the main problem over here is that even though it connects, or even though it considers each and every data points within a space, it may also include, or it may also learn about a noise, but actually it is not needed. So it is how can we say that it is overperforming? The model is overperforming, right? So this we call it as an overfitting. Here it includes a noise also. So and then next comes the optimal fitting. So optimal fitting tries to cover all the data points which is given over here, and it is more approximately it covers all the data points. See here, there's a difference between these two diagrams in compared to this. Okay, so this is underfitting. It is not covering all the data points. This is overfitting. It will cover all the data points, but the main drawback is that it also includes the noise. But when you take this one, it is going to cover almost all the data points approximately. So we can say this is a trade-off between an underfitting as well as the overfitting. That is in case of a regression. In case of a regression, we'll be having a diagram just like this. When you go for a classification, what I've said previously is that we need to group together the objects, or it may be anything. So suppose when I take a class, I want to divide the class into two groups. How can I divide? I can take the gender. Okay, I can take the gender. The gender may be either maybe of a male or either maybe of a female. So based that when I take a gender male, they'll be having some similar characteristics. I can club those members into one group. And when you take upon female, they'll be having a common characteristics or similar characteristics. So likewise, I can divide those into two groups based upon the similarities. Okay, so likewise, when you consider here it consists of blue color dots and then red color dots. So approximately I am classifying this into two groups. Okay, but why this is I am saying this is an underfitting is that here also include a few one or two red dots will also be included over here. Some few data points will wrongly interpreted into a specific class. Okay, so this we call it as an underfitting. And when you go for overfitting, see this is here the data points has been scattered over here and there. Okay, so here it may also include some few members of others groups. So these all will comes under it. But actually, when you go for it, has to be traversed from those data points that belongs to a class A also, and then we need to come across over here. So this tends to be somewhat clumsy. So that's why I'm saying that this is generally it includes the noise levels. So when you go for an optimal fitting, the optimal fitting maximizes or maximize the separation between the class A and the class B. Okay, and then next comes the deep learning. So in deep learning also we'll be having and underfitting, optimal fitting, and then overfitting. And what are the solution? How can I overcome the overfitting problems? The solutions that can be provided with the help of overfitting problems is that regularization. So L1, there are several classification of a regularization. That is L1 and then L2 regularization. So what is the concept behind the L1 and L2 regularization is that so when I take an L1 regularization, right? So it will generally most of the values is zero. It will generally makes most of the values as zero. Why it makes most of the attributes value as zero is that suppose I'm taking the same example, that is age and then date of birth. Okay, if the date of birth is given, automatically I can derive the age, right? So, but both the attributes is not needed at the current time. Okay, so if I include these two attributes within a table, I can provide a value for date of birth alone instead of age. Okay, so under age column, we'll be giving a value zero. So suppose likewise, if we check the various features, we need to find out what are the relevant features needed for our problem and which is not. If the relevant, if the feature is not needed, will automatically assign the value zero. Okay, so just imagine that if I'm taking 100 features, and if suppose among the 100 features, if suppose 50 features tends to be the value tends to be zero. Okay, automatically you'll be getting graph representation or matrix representation. Most of the values tends to be zero, right? So this will lead to one sparse model, right? So if the number of entries, most of the entries tends to be zero, we'll be getting a sparse model. Or when you say about in terms of a matrix, it is also called as a sparse matrix. Okay, so that comes under an L1 regularization. And when you go for L2 regularization, okay, it also tries to shrink the values to 1 0, but it doesn't make it as a zero. Whereas in case of L1, it will make if the feature is not needed, it automatically assign the value zero. But when you take an L2, it doesn't provide the value as zero, but the tendency of that L2 regularization is that it almost shrinks those value to nearest to zero. Okay, and then what comes the next thing is that the next thing is the dropout. So dropout is randomly turning off the neurons during a training. If it is not needed, if it is not relevant to the problem, so automatically this can be dropped out. So we might have seen in various situations, right? If the problem that has been or if when you take some types of examination, so if a question is not a question, as well as the options provided to those questions is of a different nature. So the correct answer is, if it is not provided in the correct answer is not provided in an option, automatically the questions can be dropped off, right? So when you find out in neural networks, if it is of no use, we can automatically drop that particular neurons. So that comes the dropout. And then data augmentation. So generally involves in generating new training examples, new training samples. So how can we choose the samples is that we need to select the subset of samples from various populations. So because we need to train the machines on a few trained data as well as the unseen data. So these are the various solutions to handle an overfitting. Among the one of the popular thing is that regularization. And then the next thing is that scaling for ML for real world impact. So the first thing is the distributed training, federated training, and ML on the edge. So what do you mean by an distributed training? Okay. So distributed training models generally it acrosses the multiple machine to handle large data sets and speed up training. As you know that since the term itself involves distributed, there is no centralized server, or there is no centralized thing to be monitored. Okay, so everything is actually it is dispersed over to each and every model. So what are the various types available over here is two different types of parallelism available. So first thing is that data parallelism, and then the next thing is that model parallelism. So when you take a data parallelism, it splits the data across multiple machines, and each computer gradients independently. So since the data can be split across multiple machines, there is no dependency, right? So a work has been divided and it is provided to each and every model, or each and every local server. Each will perform its action. It will provide the intermediate results finally, and altogether they can be combined to provide a final solutions. And then the next thing is that model parallelism. It splits the model across the machines for large models. Okay, what are the strategies here we are going to follow in distributed training is that synchronous as we can classify the strategy into two types. That is excuse me, synchronous and then asynchronous. When you take a synchronous, all the machines synchronize gradients, ensuring stable conversion. But here it is slower training. When you take an asynchronous, the machine update independently and it works faster, but it is less stable because since it updates its value independently, it is somewhat faster, but it is less stable. Okay, what are the main benefits of using the distributed training is that a faster training can be provided, and a large number of data sets can be handled. And one more thing is that here everything should be collaboratively work in order to provide a better solutions. Okay, if there is no collaborative, or if there is no integration between all those models, it is of no use, because each and every model is independent of each other, right? So if a particular model produces a solutions, this may provide an output or partial output to the next upcoming model, which in turn can be used by that model, and altogether if it works properly, can finally it will produce the output. And next comes the federated learning. So when you take a federated learning, so here this is also a decentralized approach, right? So where the multiple devices collaboratively it just train a model without sharing the raw data. So each and every device computes its local update, and that local updates are sent to a central server for aggregations. So likewise here also the thing is that the work has been divided among each and every training model, and altogether each and every training model will do the actions within their local data instead of sharing their raw data. So what is the main benefit of over here in federated learning is that the data stay local on each and every devices, and moreover it improves the efficiency, that is in terms of reduces the need for large data transfer. Since it works, it is not needed upon the data which is available on other node, because every raw data is actually stored in that particular node itself. It will do the calculations and send the results to the server. And also the scalability is also included in case of federated learning. Okay, so that's here I've listed out. The main purpose is that it defines the range of models that the system explores to find the best global model by combining the knowledge from distributed data sources. Okay, and each and every model, since I have said each and every model is going to have its own local updates, so that need to be shared only to the server for further aggregation. And then ML on the edge. So ML on the edge, the machine learning models works on several devices such like that smartphones or IoT sensors, just like this. And when you take an application for this, it is used for real-time language translation and predictive maintenance in industrial equipment. So I think you might have been aware of real-time language translation. So suppose if I know English, if it is not known by you, and if you know some other language, I need a translator, right? I need a translator. It may be a person or it may be a machine who was well versed about my language, that is English, and about your language, those who can translate between us. Okay, so here it plays a major role. And also in predictive maintenance in industrial equipments. Suppose if a particular component within an industry has been failed, automatically it has to be predicted, and it should be provided in advance, right? So that the delay can be avoided. And then next comes the real world applications. So real world applications, here I've listed out a few, that is healthcare, finance, and then autonomous system. So when you take a machine learning application in healthcare, it is used to monitor the record of a particular patients, right? That is smart health record, and then personalized medical treatment based upon the symptoms or based upon the severity of that disease. Automatically, a personal suggestion have been given by each and every doctor in terms of to cure the disease. And then if they are going to have predefined symptoms, for example prolonged coughing or sneezing just like this, there may be a possibility for the disease occurrence, that is TB. So based upon the previous history of the person as well as the current symptoms which is generally occurs in that particular person, we can able to predict which disease have been attacked by that particular person, right? And then the next thing is that the disease identification and diagnosis. As you know that suppose when you go for suppose if a person has been affected by a brain tumor, so with the help of an such kind of algorithm, we can easily find out where that particular, in which area of a brain he have been affected. Okay. And through this we can also provide suggestions of a drug to be taken by the persons. So this is a simple scenario of machine learning application in healthcare. And the application of machine learning in finance industry. So in finance industry, how far it is working, right? So we just gather the client profile management, and then automation of operations, and efficient risk assessment, and then fraud detection, effective data management, intelligent trading, and advanced marketing. And this is a simple example for autonomous system in traffic. Okay, so while a vehicle has been moving, suppose when you take self-driving cars, so various sensors have been placed in that cars in order to diagnose or in order to identify what are the objects or a particular person or objects which is moving in front of the car. If suppose if a person or any other object is coming or moving in front of the car, automatically the automation, the sensor need to detect those details, and automatically it need to reduce the speed of a car, right? And also it will give the accurate predictions how easily we can reach the destination. So what is the shortest distance to reach the destinations? And suppose if it tends to be the traffic tends to be very high, it will automatically indicate. So all these together are under the control of sensors. So here for that I'm giving you the simple diagram, that is object detection, traffic signal recognition, then subfunction, and then transfer signal recognition, and then route optimization, etc. like this. So in real-time applications also this is well used. And what is the future of machine learning? And the future of machine learning is that emerging trends and democratizing AI. So when you take an emerging trends, here comes the so when you take and democratize it, AI, okay. So this making it generally makes to refers to an AI tools and technology which should be accessible to everyone. Either they may be an expert or they may be a non-expert, or they may be in business or they may be in individuals. So the main target is that the AI tools and techniques have to be reached for each and everyone around the world. So what are the main benefits of using this thing is that increased accessibility, and then faster innovation, and then business growth. And what are the main challenges we need to focus on? This one is that ethical concerns, and data privacy, and then skill gaps. And when we come for the applications of democratizing AI, is that no code or a low code platform. So if there is no code or low code platform, this can allow the non-technical users to create an AI models. Okay, so they are not independent, or if I know the code only I can able to perform well. This is not the scenario. So it generally allows even a non-technical user to create an AI models. And coming over to the other applications, AI powered tools, that is making AI driven applications which is available in industries like healthcare, education, and then finance. And then next comes the quantum ML. So this quantum ML generally deals with quantum computing, which combines the quantum computing as well as the ML to leverage the quantum machines for faster and more efficient computation. And what are the main benefits of using this quantum ML is that here the complex problem can be solved faster when compared to in classical computers. And then the challenges involved over here is that the hardware limitations and then scalability issues. And the application thing is that quantum chemistry, and then optimization, and then cryptography. And when you go for neuromorphic computing, so as the term itself implies that neurology generally leans with the human brain processing systems, that is nervous systems, right? And here, this generally mimics the human brain structure and function in ML model using artificial neurons and synapses. The benefits of thing is that energy efficient, and then it is ideal for edge devices. The challenge is the same, just like that for quantum ML, complex hardware and algorithm development. And the main application area of this one is that robotics, and you take an autonomous system, real-time decision making system, and then recommender system. Okay. So when you go for democratizing AI, there are open source tools and platform available. An example for open source tools and platform is that Hugging Face, and then TensorFlow, XSL, etc. So this increases the accessibility for smaller organization. And then go for the case studies, and the thing AlphaFold and Tesla's autonomous driving pipeline and GPT models in content creation. So when you take an AlphaFold, it solves a protein structure prediction with near human accuracy and a revolutionizing biology and medicine purposes. So it is used to suppose if I want to find out an uh, hybrid. So when I take a plant, if I want to find out the hybrid, a new variety of a plant, so we'll select the base plants. We will select the two base plants, and based upon that, we'll do an cross pollination, and then we can get the new variety, right? So here, likewise in human in biology, or it is generally in medicine, for a particular disease, we can able to provide an preventive measures by the help with the help of providing medicines to the patients, or if a particular disease has been affected, so we can propose the thing so that we may increase we can give a medicine so that his life flow, if his life period have been extended. So that in case here the alpha food is mainly used. And I've said the thing about Tesla's autonomous driving pipeline. So this is generally used for taking a real-time decision making. So in previous slide, I've given you situations for traffic flow. That is the best example for Tesla's autonomous driving pipeline. And then GPT models. This GPT models is used in. It is going to have an impact in various AI-driven writing, coding, and creative outputs. And the conclusion is that the advanced ML technique enhance efficiency and innovation, optimization and scalability ensure practical implementation, and future trends will refine computing and then add automation. Thank you. And if any query is that, you can post your queries. I hope I have shared a few knowledge with you. Thank you.
Yeah, thank you for our participant. If you have any questions for the speaker, please add them to the chat or you can raise your hand. Hello, Miss. We have a question already
Okay,
right
okay,
in the
okay.
chat.
I'll go upon the question. What are the key differences between supervised, unsupervised, and reinforcement learning? And in what situations? Okay. When you take supervised learning, let me say about supervised learning, right? The term says that supervised, it is under the control of the supervisor. So the simple example is that a teacher and then student, okay, or it may be tutor and then student. I'm teaching the lessons for you, right? You are just observing me, and you can gain the knowledge from me. Okay. If I'm taking, if I say that this is a phone, right? This is a phone. It is used to go have a feature just like this. Rectangle shape, etc., like this. So if the image has been provided to you and trained with you that particular model, if suppose in near future, if the same kind of devices have been provided to you, you can automatically identify it, this is the phone. Okay. So where we can have both input and the corresponding output. The machine is trained with the help of labeled data, which is nothing but both input as well as an output data, right? So when I take a fruit, for example, when I take a fruit, apple, okay, assume that it have been shown to you by your parent. Here, your parent is a supervisor, right? He's saying that this is apple, this is going to be in red color, and it is going to have an apex at the top, okay, and it is going to have a light bulge feature just like this. So if the apple is shown to you once, so you can able to find out wherever the apple in any situations, so that we call it as an supervised learning. And unsupervised, when you go for unsupervised learning, it is not under the control of the supervision, right? Suppose if a new situation is provided to you the first time you are entering into a college or entering into a class, you are unaware of that situation or environment, right? You have to learn day by day, so that we call it as an unsupervised learning. Suppose when you go for a reinforcement learning, if an action have been performed by you, if it is going to be a right action, you will be awarded, or if it is going to be a wrong action, you will be punished. So that we call it as a reinforcement learning. And one more questions you have raised is that what are the advantage and disadvantage of using deep learning models compared to traditional machine learning models? So the advantage of deep learning is that automatic feature extraction. So there is no need for manual feature engineering. We doesn't need to find out manually which feature is relevant for producing the output and which is not. Okay, automatically the feature selection has been done with the help of a deep learning, and also the high performance of complex data. Since we can provide complex data in a sense, each and every time we cannot provide or enable the query with the help of text messages. It may include a voice message or image or speech, etc. Like this. So high performance can be provided on complex data, and moreover, the scalability is also one of the beneficial of using a deep learning. From the large data sets. Instead of using a CPU, that is central processing unit, we can move from CPU to GPU, that is graphical processing unit. So these are the basic advantage of deep learning. And then when you go for a disadvantage, since it deals with a complex problem, right? Automatically the high computational cost will also be increased, and large data requirement is also needed because we are in need of labeled data. So since the labeled data involves both input and output, a large data requirement is also needed, and a lack of interpretability. So this generally deals with the black box things because everything cannot be revealed to the user. Some abstraction need to be performed on that particular area. So this is a benefit of both using deep learning as well as the costs. And I can address the next question. What are the biggest challenges in training a machine learning model? And how can we address them? Okay, very good, fine question. So, training a machine learning model generally involves several key challenges. So, the first thing is that we need to deal with the data quality and the quantity. And the next thing is that overfitting and then underfitting, and then feature engineering, hyperparameter tuning, right? So if the quality of the data is of poor, it is of no use, right? So for this, in order to improve the quality, we'll be doing data cleansing and then augmentation and collection strategies. So data cleaning generally deals with the missing values. I think you might have been known somewhat about database systems. So this generally deal with the cleaning generally deal with the missing values or redundant values. All these data need to be focused. And then overfitting and underfitting, what I said previously, underfitting works well only for a trained data and not for an untrained data. Overfitting generally covers all the training data as well as the new trained data. But the main drawback of this is that it also includes the noise one. Okay, so in order to avoid the overfitting, we can go for some of the solution, that is regularization, cross validation, and training data. And moreover, the next thing is that next challenge is that feature engineering, based upon what are the features I need to include in order to train the model. So that third thing. And the another one is the hyperparameter tuning. This may be also be a challenge. And then computational cost, explainability, and interpretability, and then data drift and model decay. That is data drift and model decay. Generally, it is nothing but changing the data distributions. It generally affect the model performance over time. Okay, so how can we provide a solution in terms of continuous monitoring and periodic retraining? Is there any other queries? I think there is any other query. Ma'am, shall we end this session?
Yeah, yeah. Thank you so much for answering. I guess no one else is in again. Yeah, before I close this event, for our participant, please open your camera. I will take a picture on the one of three. Okay, one, two, three. Okay, another one, two, three. Thank you. Thank you for your contribution. Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Mohambigai for the wonderful information and sharing your knowledge. We hope this information will be beneficial for our participants. At least we hope for collaboration in the future with Chandigarh Group Colleges India. The visiting lecture for today, India. We hope to see you soon. Thank you and have a nice day. Goodbye.
Okay, thank you so much, ma'am, for giving me the opportunity for providing a few knowledge which is known by me. Thank you. Thank you for every possibility.